Hello my dear friends, welcome back to our YouTube channel. This is your ADC Maths. So in this class, I am going to find the eigenvalues and the corresponding eigenvectors for the following 2 by 2 matrices. I am considering only 2 by 2 matrices in this video lecture, right? Let us see that. As we already know that what is the order, it is 2 by 2 matrices, there are only 2 eigenvalues, right? Okay. Now, what is the corresponding characteristic equation? So, to find the eigenvalues of A, what happened? How to find the eigenvalues of A? As already we know that the characteristic equation is determinant of the characteristic equation of A is given by determinant of A minus lambda I is equal to 0, right sir? But for the 2 by 2 matrix, as we know that the 2 by 2 matrix, the equation is lambda squared minus S1 lambda plus S2 is equal to 0, isn't it? As already know. What about S1 Kanna? S1 is equal to sum of the leading diagonal elements. So 4 plus 2 is equal to 6. What about S2? Yet S2 is the determinant of E. So determinant of 4, 1, 3, 2. So how much? 4 2s are 8 minus 3 1s are 3. So it's equal to 6. So when I substitute S1 equal to 6, S2 equal to 5, we will get the second degree polynomial quadratic equation lambda squared minus 6 lambda plus 5 is equal to 0. So this is the second degree polynomial. Why we get the second degree polynomial? Tell me. Because the given matrix is 2 by 2 matrix. Isn't it? Now, how to solve this quadratic equation? The sum of the roots is, I think so, it is 6. The product is 5. The sum is 4 1 3 2. Okay. The sum of the root is 6. The product is 5. So what are the two numbers? I think so 1 and 5. Right, sir? So this can be as lambda minus 1 into lambda minus 5 is equal to 0. The sum of the root is minus 6. Product is plus 5. So minus 1 into minus 5 is plus 5. Minus 1 plus minus 5 is minus 6. So lambda is equal to 1 comma 5. So there are two roots. These are the eigenvalues of the given matrix A. Why we get 2? Because of it is 2 by 2 matrix. Right, sir? So solving this quadratic equation, there are many techniques are there. You may use the formula as well. What's the formula? Lambda is equal to minus A minus B plus or minus square root of B squared minus 4AC by 2A. What's the name of this formula? It's called quadratic formula, isn't it? So you may apply this also, we get the same answer. What is A, B, C? Small a, B, C. Small a is equal to the coefficient of lambda squared 1. B is the format is A lambda squared plus B lambda plus C equal to 0. Suppose this is the quadratic equation. A is the coefficient of lambda squared, B is the coefficient of lambda, C is the constant term. So in this equation, A is 1, B is minus 6 and C is 5. Isn't it? Right? It's clear? Now substitute in this formula, we get lambda is equal to minus of minus 6 plus or minus square root of minus 6 whole square. So those who are not familiar with this factorization method, please apply this quadratic formula. It will take some time, but you can do this by rough work. Once we get the answer is very important because it is case sensitive. Plus or minus is very important. So once we make a mistake here, then everything becomes wrong. So if you are not familiar to solve the quadratic equation, you please try using this quadratic formula. It doesn't matter. Okay. So minus 6 whole square minus 4 into A into 1 by 2 into 1. So which gives plus 6 plus or minus square root of 36 minus 20 is 16 by 2. So is equal to 6 plus or minus 4 by 2, otherwise 6 minus 4 by 2 or 6 plus 4 by 2. What is 6 minus 4? 2. 2 by 2 is 1 and 6 plus 4 is 10. 10 by 2 is 5. So I think so we get the same answer, isn't it? So this is the lower class technique. By using the quadratic formula, you can do it this by rougher. Okay. Otherwise, you are familiar with the factorization techniques. You can do this by factorization technique as well. No problem at all. But the idea is, after getting the characteristic equation, solving, we get the eigenvalues. That's it. We get. Once we solve this equation, we get the eigenvalues. Now, how many eigenvalues you have? 2. What are they? 1 and 5. Now, what are the corresponding eigenvectors? What are the corresponding eigenvectors to this lambda value 1 and 5? So let us how to find the eigenvectors. How to find the eigenvectors? Let us see that the eigenvectors of A. The eigenvectors of A. The eigenvectors of A. How we will get? The eigenvectors of A are given by the eigenvectors of A are given by the eigenvectors of A are given by the matrix equation. What matrix equation? Determinant, no determinant, is lambda A I into x equal to 0. A minus lambda I into x equal to 0. So what's the mean that A minus lambda I? Subtract lambda from the diagonal wise. May I write, sir? Subtract lambda from the diagonal wise. So we may get 4 minus lambda, 2 minus lambda. Subtract lambda from the diagonal wise. Because what is I, sir? We know I. What's I? 1, 0, 0, 1. What about lambda is there? So it is lambda 0, 0, lambda. What is the A? A is 4, 1, 3, 2. So to subtract this, what we will get? 4 minus lambda. Here 2 minus lambda. What about this term? 1 minus 0 is 1. 3 minus 0 is 3. So the change is only in the diagonal alone. Right, sir? So this is A minus lambda I. What about I stands for? I stands for the identity matrix. What about the X? X is the non-zero column matrix. Here X can be considered as X1, X2. Why there are only 2? Because of this is the 2 by 2 matrix. This is equal to 0 matrix. Once again, 2 zeros. So 2 by 2 matrix. So that's why we get X is equal to X1, X2. Suppose 3 by 3 matrix, we take X1, X2, X3. 0, 0, 0. That's it. Now, in this left hand side, it is a matrix multiplication. First row into the column. So 4 minus lambda into x1 plus 1 into x2 is equal to 0. So this is the fundamental theorem on algebra. If there are n unknowns in the given system, then at least there are n distinct equations. So how many unknowns here? x1, x2. So this is my eigenvector. So there are two unknowns. So there are two equations. So first one by 4 minus lambda into x1 plus 1 into x2 equal to 0. Second one by this row and the same column. So 3 into x1 plus 2 minus lambda into x2 is equal to 0. So this is my system of equation, star equation. So in this star equation, it is in terms of lambda. It is in terms of lambda. Let us substitute the lambda value one by one, which will give the corresponding eigenvector to each eigenvalue. Got it? Now can I substitute lambda is equal to 1 first case? So my case number 1 is, now my case number 1. What's the case number 1? Case number 1 is by putting lambda is equal to 1. By putting lambda is equal to 1 in the star equation, we get, by putting lambda equal to 1, 4 minus 1, 3 x1 plus x2 is equal to 0. First equation. Second equation, 3 x1. What about 2 minus 1? Because lambda equal to 1, 2 minus 1 is equal to 0. I think so. These equations are identical. These equations are identical. Same, isn't it? these equations are identical, same. So that means that it represents only one equation. 3x1 plus x2 is equal to 0. I need the x1 and x2. Very simple logic. I am going to use the ratio concept. Let us see that 3x1 is equal to minus x2. From this, x1 by is equal to x2 by. Let us see that. This is the ratios property. Let us consider the coefficients of the variable. Let us cross multiply to the next side. So what's the coefficient of x1? 3. Let us move this into the next side. This becomes 3. This minus as it is written here. What about the coefficient of x2? 1. It is coming here. So what is the meaning of this one? For example, if we take an x1 is the price of the cost of the pencil. x2 is the cost of the pen. So 3 pencils cost is equal to the price of 1 pen. So that is the concept. So once again repeat this. How to solve this analytical equation? Very simple. Consider the coefficients. Let us push into the next side. So x1 by 1 equal to x2 by minus 3. So the first eigenvector corresponding to lambda equal to 1 is x1 is 1. x2 is minus 3. Once I repeat that, my x is x1, x2. My x is nothing but x1, x2. Let us find out small x1, small x2 to each values of lambda. So when I put substitute lambda is equal to 1, I get the identical equation. Most probably in all 2 by 2 matrices you will get only the identical equation. Understand? So 3x1 plus x2. Let us push the coefficients to the next side. Then keep the sign as it is in the second side. We get x1 is equal to 1, x2 is equal to minus 3. That means the cost of the pen is 1 pen is equal to the cost of the 3 pencils. So that's the mean that. Otherwise, this is the ratio property. So this is often called as the eigenvector corresponding to the lambda equal to 1. What about the second eigenvalue? Lambda is equal to 5. So case number 2. What's case number 2? Case number 2. Let us substitute lambda is equal to 5 in the star equation. So let us use the same equation. See that? Let us use the same system of equation by putting lambda equal to 1, 5, or what are the values we have. The eigenvalues substitute, which will give the corresponding eigenvectors. When I substitute x is equal lambda is equal to 5 here, 4 minus 5 is minus 1 into x1 minus x1 plus x2 is equal to 0. What about the second equation? 3x1, 2 minus 5 is minus 3x2 is equal to 0. Once I repeat this, substitute lambda is equal to 5, 4 minus 5 is minus x1 plus x2 is equal to 0. Second equation, 3x1, lambda equal to 5, 2 minus 5 is minus 3x2. I think so these two equations are identical, isn't it? How? Tell me. Yeah, I think so. When I divide the second equation by minus 3, I am getting the first equation, isn't it? When I divide this by 3, I am getting that x1 minus x2 equal to 0. When I multiply this by minus sign, we get x1 minus x2 equal to 0. So these equations are identical. So most probably in the 2 by 2 matrices, the equations comes identical only. So what is the equation here? When I divide this by minus 3, I am getting minus x1 plus x2 is equal to 0. I think so this is the same. I think so this is the same. So both are same. So minus x1 plus x2 equal to 0. Otherwise minus x1 is equal to minus x2. That means that x1 and x2 are same. x1 and x2 are same. What about the coefficients of x1 and x2? 1, 1. So what about the x1 by x2 by? So x1 by 1, x2 by 1, because the coefficients are 1 only, no. Because as you take, this is some ratio, then this could some constant k. So k is equal to 1, I am getting 1, 1. Suppose k is equal to 2, we get 2, 2. K equal to 3, we get 3, 3. But in here it is scalar. So it is nothing but 1, 1. Simple. The minimum value for the scalar is 1. So 1, 1. So what is the eigenvector corresponding to lambda is equal to 5? It is 1, 1. It is 1, 1. So this is the method to find out the eigenvectors of 2 by 2 matrices. 2 by 2 matrices. Is right? Now what about the second problem? The second sum is 3, 4, 4 minus 3. You please try on your own. I can give the answer. You may verify the answer. Okay, you may verify the answer. 3, 4, 4 minus 3. I can give the answer here. You please try on your own. The eigenvalues are lambda 1 is equal to 5. Lambda 2 is equal to minus 5. Can you check the answer? Lambda 1 equal to 5. Lambda 2 equal to minus 5. The corresponding eigenvectors are x1 is equal to 1 minus, that is 1, it is 2, 1, and x2 is equal to 1 minus 2. So kindly check this answer. This is the second sum. This is the corresponding answers. What is the answer? Lambda 1 equal to 5 and lambda 2 equal to minus 5. I can give the hint for you. I can give the hint why this is coming. The minus 1, that is minus 5 and plus 5. Let us see that. What about the characteristic equation? Lambda squared minus s1 lambda plus s2 is equal to 0. Is right? What about s1 for the matrix, second matrix? 3 minus 3. What about 3 minus 3? This becomes 0. Isn't it? What about s2? s2 is the determinant of the matrix. What's the determinant? 3 into 3 minus 9 minus 4 fours are 16 is equal to minus 25. Let us substitute the s1 value and s2 value. We get lambda squared. Now s1 value is 0. So let us omit this value. What about s2? Minus 25. So lambda squared minus 25 equal to 0. So lambda squared is equal to 25. And lambda is equal to plus or minus root 25. Otherwise lambda is equal to plus or minus 5. So I found that lambda equal to plus 5, lambda equal to minus 5. Now find the corresponding eigenvectors by using this concept. By using this concept, you will get the eigenvectors 2, 1 and 1 minus 2. Try this question. Thank you so much.